All right, so let's take a look at the formulas first. Just like all the other formulas, we have three, one for sine, one for cos, one for tan. And they're called reduction formulas because what we're doing with the formulas is we're taking an exponent and we're dropping it by 1. We're going to take a squared and turn it into just a regular cos. Or we're going to take a sine squared, reduce it to a regular sine. Yeah, they drop the exponent by 1. So we'll start with sine squared theta. Sine squared theta is equal to 1 minus cosine of 2 theta all over 2. Not the only formula we have for sine squared. We have our Pythagorean identity, sine squared plus cos squared equals 1. The problem with that is it takes a sine squared and turns it into a cos squared. We want to get rid of the exponents. This takes a sine squared and turns it into a cos without an exponent, which is nice. If I'm solving equations and I want to get at theta, this involves square roots and inverse trig functions. This just involves inverse trig functions. One is going to be easier to undo than the other. Cosine's formula looks almost identical, except the operation in the middle changes. 1 plus cos 2 theta over 2. We like that. Makes them easier to remember. They form a nice pretty pair. Sine is the minus, cosine is the plus. And then we get tangent. Tan squared theta. And tan's formula comes from the definition for tangent. Tangent is what over what? It is opposite over adjacent, which matches up to sine over cosine. Yeah, so we're taking the sine formula, dividing it by the cosine formula. Since they're both got 2's on the bottom, we know the 2's are going to cancel. And I'm just going to be left with 1 minus cos 2 theta over 1 plus cos 2 theta. It's just the ratio of the sine and the cosine functions. Yeah. I know where tan came from. I can kind of see where cos came from because I know cos squared is related to sine squared. So the question is, where is the sine squared coming from? And the answer is that these come from our double angle formulas. And we're going to take a look at that to see if we can come up with the expression for sine squared. And I can see in the formula for sine squared, there's a cos of 2 theta. So let's take a look at that double angle formula for cos of 2 theta. I want to turn cos of 2 theta into a sine squared. I'm going to use the formula that Emma used for our warm-up, which is 1 minus 2 sine squared theta. That was our double angle formula. And I want to solve it for sine squared. So we got to do some algebra. So I want to get this guy by itself, right? I want him to be isolated, which means I'm focused on just the right-hand side of the equation. What can I do to the right-hand side of the equation to get sine squared by itself? Suggestions. Take about 30 seconds, talk to your neighbors. What can I do to start solving for sine squared theta? Something equals 1 minus 2x squared. How do I get the x squared by itself? Now 20 more seconds. All right, do I have any volunteers before I start calling on people who's got a suggestion? I heard you talking. You must have a suggestion. Did Jennifer's table come up with something? What would you guys suggest? What would you suggest?
Divide.
Divide. What are we dividing by? Cosine. So we could. There's nothing mathematically wrong with that. The problem is that's going to move cosine this way. And ultimately, I want to move the stuff that's not sine the other way. So it's not wrong, just probably not helpful here. Does somebody else have another suggestion? I want to get rid of the stuff over here. How do I do it? Reverse PEMDAS, guys. Start with the addition, subtraction. So yeah, let's just subtract 1 from both sides. That's perfect. Perfect. Minus 1 plus cos 2 theta equals minus 2 sine squared theta. I agree. Slightly prettier. You will notice I intentionally left the minus 1 in front, minus 1 plus cosine, instead of cosine minus 1, because I know what I'm aiming for. And that helps. Very good. Next step, Yaya says, let's divide by negative 2. Whoops, not 22, negative 2. On the right side, that fixes the problem. Sine squared's by itself. On the other side, I want the 2 on bottom. I don't want the minus sign. So this is going to change that to a positive. This is going to change that to a negative. Dividing by a negative flips the sign on everything, which leaves me with a positive 1 minus a cosine 2 theta all over 2, which is exactly what we wanted to show. Yay! While you are jotting that down, you will notice a pattern. These formulas came from the double angle formulas yesterday. The double angle formulas came from our addition and subtraction formulas from last week, right? Those formulas came from a distance formula that we learned way back in semester 1. All of these formulas are interconnected. And as experienced mathematicians, what you will often see happen is we will memorize the core set of equations and then remember that we just need to do algebra to get the others. Because the algebra rules reverse PEMDAS to solve for something. That's always the same. I don't have to memorize something new. I can get a whole bunch of equations from just a core set of a few. Yeah. So algebra is really powerful if you can remember how to do algebra, because then you can pack a whole lot of information down into a very small space in your brain. I don't expect, with your first pass through college trig, that you're going to have all that memorized, right? I'm going to give you an equation sheet. But it's still helpful to realize that you can get from one to the other with a little bit of algebra, and that those algebra skills still apply, yeah? Okay. Questions before we start some examples? I'll take the giggling as a no. Okay, let's do some examples. First example, we have the function cos 4x, that is cos x to the fourth power, cos x times cos x times cos x times cos x. And we want to rewrite it as a trig expression that has no exponents in it, exponents of 1 only, which are the ones we don't write. The question is, how do we do that? And the answer is our power reduction formulas. I'm going to start with cos 4x. And I know that cosine of 4x is cosine squared x times cosine squared x. Also known as cos, oops, I know how to write, cos squared squared. Yeah. And cos squared is something we have a formula for. So let's use the formula we have on the cos squared x. We're going to replace each cos squared with its reduction formula. So I'm going to end up with a reduction formula for the first cos x squared, reduction formula for the second, because there's 2 of them, yeah? Cos squared times cos squared. Now we're grabbing formulas. For cosine squared, 1 plus cosine 2x all over 2. Not so bad. Oh my good lord, there's like 3 of them. You guys all wait for 6th period? Frowny face. I didn't mean to zoom out there, sorry. There we go. All right, next is the algebra. I did the trig, I did the formula replacement. Now I'm doing algebra. When we multiply fractions, we multiply the numerators, we multiply the denominators. So my numerator is going to be 1 plus cos 2x times 1 plus cos 2x. Binomial times a binomial. On the bottom, 2 times 2 is 4. Happy face. That is less scary. Each of those parentheses in the numerator has 2 terms, 1 plus something, 1 plus something. Those are binomials. We have 2 ways to multiply binomials. How do I multiply binomials? X plus 5 times x plus 3. How would I multiply them? Louder, Michaela. Yeah, FOIL's one option. That's the one I default to. Or the box method. Perfect. Yeah, let's FOIL these guys out. First, outer, inner, last. So first, 1 times 1 is 1. We like that one. Outer is going to be a 1 times a cos 2x, which is just cos 2x. Very good. FOIL. So inner is next. Inner is cos 2x times 1, which is also just cos 2x. And then last is going to be cos 2x times cos 2x. And I'm pretty sure that that is cos squared 2x. Cos 2x times itself. We get a squared. Denominator is still 4. Very good. I see 2 like terms that we can add together. I see a like term here and a like term here. So we're going to take that thing with 4 terms and reduce it down to 3. And I'm going to do 2 things at once. I'm going to group the like terms. Those 2 middle terms are going to come together. And I'm going to split into separate fractions. So first term is going to give me 1 over 4. Second term is those 2 cosine 2x's. 2 cos 2x over 4 plus, and then I get a cos squared 2x over 4. And I see something that can reduce and something that can be replaced. So 1/4 is 1/4. Don't care about that. Middle fraction. What can I reduce? 2 and 4. They're both divisible by 2. This is going to become a 1. This is going to become a 2. 1/2 cos 2x. Very good. And this guy is a squared. We have a formula to reduce that. So let's rewrite. We have 1/4. I have a 1 and a 2, so 1/2 cosine 2x. And then I have a 1/4. And then cosine squared 2x gets a reduction formula. And off to the side, I'm going to write the original, and we'll see if we can figure out the new. So the original is cos squared x is 1 plus cos 2x over 2. We do not have cosine squared of x. We have cosine squared of 2x. The question is, what does that do to the formula? Who came back? Denio came back. Jennifer came back. Nicholas came back. Very good. So I'm going to stick the things I know stay. The 1 shouldn't change. The 2 in bottom shouldn't change. I should still have a cosine. The question is, what goes in the cosine? So let's look at the pattern. The first took a single x and doubled it. If I take 2x and double it, what should I get? 4x, yeah. Yeah. We take an exponent of 2 and turn it into a multiplication factor inside. Cos squared becomes cos of 2x. Cos squared of 2x becomes cos of 4x. So when I substitute in here, it's 1 plus cos 4x over 2. That was the second piece of trig. We had to do a second substitution to get rid of the exponents. Now it's just making our answer pretty. Yay. Mathematicians like pretty. So 1/4 doesn't change. 1/2 cos 2x doesn't change. Here, I get two separate fractions. I have a 1 over 2 times a 1 over 4. 4 times 2 is 8. So 1 over 8 plus, and then I have a cosine of 4x over 2 times 4, which is cosine of 4x over 8. One more simplification. I see like terms. Where are my like terms? Frowny face, Nati, where are my like terms?
The 4 and the 8.
Yes. Gold star to Nati. Very good. 1/4, 1/8. Those are the only things that are just numbers. Perfect. Yeah. So I got to do a little number math. I need to know what 1/4 plus 1/8 is. When I add fractions, what do I have to do to the denominators? Make them the same. Very good. How do I turn a 4 into an 8? Times 2. Whatever I do to the top, I got to do to the bottom. Very good. So this is going to be 2/8 plus 1/8, which is 3 over 8. So those two fractions that Nati pointed out were like terms. When we add them, we get 3/8. We have our 1/2 cos 2x. We have our 1/8 cos 4x. Happy face. Happy face, happy face. Yeah. Little bit of trig. Whole lot of algebra. When you take calculus, little bit of calculus, whole lot of algebra. Most of upper division math is a little bit of new math and a whole lot of algebra. Yay. We're going to do one more. Yeah, we'll start it today. If we don't finish it, we'll finish it for our warm-up. But I want us to practice, because practice is good for you. Okay, next example. Similar idea. Says rewrite sine cubed of 2x with no exponents. Same process. The idea is the same. Our power reduction formulas can only take a squared down to a single, meaning anything I'm trying to reduce needs to have squareds in it. So I need to rewrite that as something with squareds in it. So I'm going to write this out long form. When we have a cubed, that means times itself 3 times. Yeah? So this is sine of 2x times sine of 2x times sine of 2x. To make a squared, I need two things. So these two together can become our squared. And I'm going to have a sine left over hanging out at the end, which is perfectly fine. So this is sine squared of 2x times sine of 2x. Maybe, if my pen works. I can't do anything to the sine of 2x. I don't need to. But I can bring that sine squared down with sine's reduction formula. So that's what we're going to do. Fraction for sine squared times sine of 2x. Yay. Who remembers my sine reduction formula? Sine squared becomes what? 1 minus cos. Yeah, 1 minus cos of something over 2. And just like with cosine in the last example, when I go from a squared to a single function, I double the angle. If my angle was 2x to start with, what is it now? Yeah, 4x. Perfect. Yeah. Yeah. Sometimes what you will see is you will see mathematicians take that division by 2 out in front as a fraction. So sometimes mathematicians will write this. But that's as pretty as that'll get. Got rid of the exponents. I only have sines and cosines. Followed directions. Yay! There are two general patterns. If your exponent is even to start with, you can do what we did in the first example. 4 is 2 times 2. If we had cosine to the 6th, I would do cosine squared to the 3rd. Right? 2 times 3 is 6. If it's odd, you're going to split off an even number to form the squareds and let the odd guy hang out by himself, like we did with the sine to the 3rd example. So 2 patterns. Even numbers, divide them by 2, group them together in pairs. Yeah. Odd numbers, you're going to group them together in pairs. You'll have one hanging out at the end by itself, like this one. Yeah. Grab the appropriate formula to reduce, do a whole bunch of algebra. Yeah? Okay. There are a couple, not very many of these, a couple of those in your homework for the week. Homework's out of the textbook. When I see you tomorrow, we're going to do half angle, and we're going to do a small group activity. Yeah? If you have questions, I'll be available tomorrow, before school, at lunch, after school. Today I have a meeting, I'm sorry.